Hey guys, sorry I can't be with you today. I'm a little sick. I'm pretty sure one of you gave me pink eye. Gross. But I'm still going to take you through today's lesson in the comfort of my office. If you see me look this way, I'm looking at my other computer screen. I've got our worksheet up there. If you see me look down, I'm writing on the iPad, taking notes and going through some examples with you. So, take this opportunity to take out a writing utensil and take out your worksheet that should have been passed out. By the end of today, you should be able to do two things. The first thing is that you should be able to solve quadratic equations with complex solutions. And the second thing is to perform basic operations with complex numbers. Not all quadratic equations have real number solutions. Take, for example, x squared equals -1. Now x squared equals -1 has no real number solutions because the square of any real number is never a negative number. Now, if you don't believe me, you can try it on your own. Take out your calculator and type in the square root of -1. And then hit enter. You're going to get something like non-real answer. And that's true. We're not going to get a real one. What we're going to get is an imaginary answer. Now, a long time ago, mathematicians created an expanded number system using the imaginary unit I for imaginary. Now, I is defined as the square root of -1. Now notice, if we take I squared, that's going to be -1, square root of -1 times the square root of -1, which is just -1. That property is going to become very useful in the near future. Now this imaginary unit, or I, can be used to write the square root of any negative number. There's a couple properties that we have to go through before we start working on problems. The first property we can take a look at, it's in your handout. It states if r is a positive real number, then the square root of -r is going to be equal to I times the square root of r. Now for example, if we look at the square root of -3, by the product property we can break that up into -1 times 3 and break it up even more. Now the square root of -1 we just saw was equal to I. Now because 3 is prime, we can't break it down or factor it down anymore. There are no perfect squares that go into 3. We leave it under the radical, and that would be our solution. Our second property actually has to do with the first property. It states that if we're looking at I times the square root of r, all of that squared, that's going to be equal to -r. Now example, if we looked at I times the square root of 3, all of that squared, exponent properties tell us that we can square each of the terms. Now I squared we just saw was -1. Now square root of 3 times the square root of 3, product property tells us we can combine those together to get square root of 9. Now the square root of 9, as we know, is just going to be 3. So our solution, or our answer to this, is going to be -3. Now we can apply these ideas, or these two properties, into solving quadratic equations. Question 1 on your handout is just like the two problems or two sample problems in the properties box. I'd like to take a look at question 2. So question 2 is x squared plus 11 is equal to 3. Now I'm going to show my work here. I'm going to subtract 11 from both sides. This gives us x squared is equal to negative 8. Now to undo the square, we must take the square root of both sides. We're left with x equals plus or minus the square root of negative 8. Now our product property tells us that we can split this up. Plus or minus square root of negative 1 times 4 times 2. Now we know that the square root of negative 1 is I, so that comes out. We know that the square root of 4 is 2, that comes out. Now all that's left is 2 under the radical. And that's where it stays. So our final answer is plus or minus 2i root 2. And now I'd like to take a look at question 4. Question 4 is 5x squared plus 33 is equal to 3. Again, subtract 33 from both sides. We're left with 5x squared is equal to negative 30. We want to get x by itself, so we have to divide by 5 first. We're left with x squared is equal to negative 6. To undo the square, we must take the square root. We're left with x equals plus or minus radical negative 6, which can be broken up into plus or minus square root of negative 1 times 6, which can be simplified into plus or minus I root 6. There's a number of examples that you can try here. I'm going to take a look at the next page, which introduces a new term and a new form. A complex number written in standard form is a number a plus bi, where a is the real part of the complex number and bi is the imaginary part. So complex number is composed of both a real and imaginary number. There are two properties that I'd like to go through today. That's the sum and difference properties of complex numbers. If you're following along on your worksheet, I'm on the back side second box. Now the sum of complex numbers is a plus bi plus c plus di. Now we can add these together by combining the real parts together and then combining the imaginary parts together. So adding the real parts, then adding the imaginary parts together. Now the difference property, I'm going to do this in red, the difference property is not adding those parts together, but subtracting those parts together. So subtracting your real components and subtracting your imaginary components. Now let's take a look at some examples. We'll look at example 1. We've got 8 minus I plus 5 plus 4I. Now we're going to combine our real components. Notice that this is addition, so we're going to add our real components together. Then we're going to combine our imaginary components together. Now up front here is an imaginary 1, so this is negative 1 plus 4I. 8 plus 5 is 13, plus negative 1 plus 4 is 3I. So, I'd like you to go through and finish the rest of these problems. Please hold on to this worksheet as we'll refer to it tomorrow. Now I'd like for you to consider 2 problems. 1. 4I negative 6 plus I. How could we write this in standard form? Second problem I'd like you to consider. 9 minus 2I negative 4 plus 7I. How could we write this in standard form? Now I hope to be back tomorrow. Hopefully I'm not as contagious as I am today. We are still on pace and we're still on track to follow our syllabus, and it does look like we will have a formative on Wednesday. The formative will cover this, as well as solving by square roots and solving by factoring. So please, please, please practice those homework problems. I will be sending you a message tonight with this homework assignment. So go ahead and bring that in tomorrow, and hopefully I'll see you then.